to also start recording for today's experiment, which is the Beer's Law. The purpose of the experiment, again, is to learn about what is calibration curve and or being able to construct a calibration curve. So purpose of the experiment. The second purpose of this experiment is to determine the concentration of an unknown solution. Okay? Again, it shows pattern. Okay? The higher the concentration, the higher the absorption of light. So if you know that, and you have a graph or a calibration curve you can do like experiment 12 and find like if it's direct relationship, then you can just use the mathematical operation. But for if it's not direct, you can create your calibration curve also yourself. So in this experiment, we are first working on calibration curve, and lastly, you would test a unknown solution against your calibration curve. The machine that is used is called SPEC20 or spectrophotometer. The background information is about Beer's law, which shows the absorption of the light by colored solution. If the solution, you have a compound that is colored and you pass light through your sample, when you have the light in a specific wavelength, so you have to have a filter that changes or blocks the rest of the light, and only a specific wavelength of that light passes through the sample. So if you have your sample here, you're going to pass the light in a specific wavelength. I0 here is the total light that has been passed through the sample, and IT is the amount of the light that passes actually. The difference is absorbed by the sample. Detector is going to detect how much light has passed through. Okay? So the idea is, the higher the concentration of the sample in the solution, the greater the absorption of the light. And experimentally, we are going to make few solutions, or solutions with different concentration, same solution with different concentration, and then experimented place the solution with different concentration in the sample holder, pass the light through the sample, read the absorption, and when you read the absorption, that absorption has to do with concentration. Okay, this is the Beer's law. Absorption is directly related to the concentration. The higher the concentration, the higher the absorption. I hope that, repeating that so many times, I hope it's clear, and if it's not, please let me know. So this is the Beer's law. The one is the path, the length for the pathway, or the light or thickness of the solution, or basically how long the light is traveling through the solution. So if you have the diameter of the test tube 1 centimeter, that's what we have. 1. C is the concentration of the solution, and this epsilon is basically a constant number. So this is the example of a calibration curve. Let's say if the concentration is 1 molar, okay, capital M stands for molar, 1 molar or molarity. So if the concentration is 1 molar and the absorption is like 0.1, when concentration is 2 molar, the absorption is 0.2, concentration of 3, absorption is about 0.3, slightly higher than 0.3, so it's not exactly 0.3, right? This number. These dots or the data points have been found experimentally. So if you have a graph with these data points, that means that these values were found by someone else did the experiment. When you do the experiment, you are going to plot the graph based on absorption versus concentration. So you have the concentration on x-axis and absorption on y-axis. You plot the graph, and when you plot the graph, now if I had a compound with concentration of 1.5, okay, concentration of 1.5 molar, what would be the approximate absorption? If I had concentration, and you can answer that question based on the graph, the calibration curve that we have on page 165. If the concentration was 1.5, what would be the approximate absorption? Can you come up with a number? 0.15? Okay, perfect. If the absorption, okay, if the absorption was 0.5, if the absorption was 0.5, what would be approximate concentration? If the absorption was 0.5, so let's draw a line. If you're told that absorption is 0.5, so you on the graph, on the you start with the absorption line, and the absorption is scaled by 0.2, so you have 0.2, 0.4, 0.6. So you have to approximate 0.5 or use a ruler and draw a line from 0.5 until it crosses the graph, the curve or the calibration curve. Okay, when it does cross the calibration curve here, so you have to basically use the graph. And so if it's a 0.5, starting like you draw a line from absorption line to cross the curve, the calibration curve, and from there you are going to draw a perpendicular line to come to the concentration line. And the number that corresponds to that would be the concentration. So if you have absorption for solution, you can use the calibration curve to find the concentration. Okay, is that clear? Did everybody figure out how do you find the concentration if we have the absorption? Yes, okay, perfect. So when you have the absorption, you find that absorption value on the absorption line. Then you draw a line to a straight line to cross the calibration curve or the graph that you have here, and then perpendicularly just draw a straight line down to the okay, see if I can draw a line again to this concentration line, and you record that number. Okay, so it's going to be 5. So the two purposes of the experiment: first of all, you don't know if the concentration is 1, the absorption would always be 0.1, and that is different from one solution to another solution. This is just an example or hypothetical calibration curve. You're not using this calibration curve. You are going to make and construct your own calibration curve with 5 solutions that you have in this experiment. So first of all, you plot a graph. When you plot a graph, you must have concentration, unit, absorption, and then you have you find the dots or the data points, you connect the line, best fitted line, and then you can use that as the calibration curve. Your last solution is going to be unknown, and with the unknown, what is unknown is the concentration, because absorption, as soon as you place in the machine, you will find, or the detector is going to read the absorption. So absorption is not unknown. What is unknown is the concentration. So when you find the absorption on this side, then you would find the point for concentration. So those are the two steps of the experiment. So the concentration of the solution is going to be calculated based on dilution, the M1V1, because you're increasing the volume, and then you calculate the concentration based on that. The wavelength that is used is 480 nanometer wavelength. I just have to tell you that a different color of the solution, or different solution, would have maximum absorption at a specific wavelength. That number in this experiment is given to you, but if you were studying like analytical chemistry, that number you should be able to find it. You have to scan through and test like 5, 6, 7 different wavelengths and find which is the best wavelength, and then you use that wavelength. In this experiment, that number is given to you, so you have to use that number. So you basically set your wavelength of the machine, the wavelength of the machine, at the 480 for this experiment. Okay. So using spectroscopy, you can find the concentration of the unknown, and then your solution must be like colored solution. Sometimes is a single compound that is colored. Other times is a chemical reaction that would generate like colored solution, and then you have to follow the procedure. Like here, you add your potassium thiocyanate, and you wait for the color to appear, and the fresh color. So you have to be consistent between the trials, or at least pay attention that it's consistent. The time waiting for each solution to give the color is consistent. Okay, questions. It's a simple concept, and if you understand the purpose of the experiment, it should be easy to follow. But you have to pay attention for the to video to get the numbers. Again, we don't have that chat box anymore. I used to write, but watch the video. Please watch the video carefully, because I noticed before I type, I actually say the numbers, and you just have to record it. If you tell me again about if you couldn't find the number, I would watch the video. If the number is not there, I will get it for you. But if the numbers are there, I would just give general answer. Again, watch the video. It has happened for all the labs, and as long as you watch it carefully, you should get most of the numbers. I haven't watched this video though, I should say. I haven't watched the video recently, so I don't remember exactly when I type the number, I say it loud enough. And but based on what I know from how I work, I actually write the number and say it loud. So hopefully you find that number. Oh, the reflection assignment, right? Bianca, are you talking about the reflection assignment? Yes, okay. Reflection assignment is like it's what do you think of this class, basically? What methods or what type of assignment it helped you to gain, the experience and the knowledge of the competency for the course, because when you register for course, you actually have a purpose for registering for the course. You want to learn some, the course competencies. The course competencies, they are the same for anywhere you take, like 1045 lab, basically, and we do have written in the books for Broward College what are the course competencies, like general education course competencies, what you're expected to learn. So basically, the experiments that I'm performing here, it's helping you to achieve that knowledge, for example. So one of the last day course competencies for students in 1045 is to understand what is calibration curve. So I design experiment that would show how to construct calibration curve. I give example of calibration curve and all that. And in general, it's not, so you don't have to go like in detail. It's just like what was the good points of this overall course for during the semester. It could be about my teaching style. It could be about how I answer questions. It could be about, I don't want to tell you what to write there, but your observation from the class and how I manage the class and how I answered questions or how I help the students or reply to emails or something. If you find anything that was good, you write there. If you find anything that was not helping your learning, then you also let me know, and I will, I will read your reflection, assignment, your responses, and try to correct it. And the same way that you write good stuff, bad stuff, you should always write also what worked, because that could be also emphasis. Anytime. You can wait. You don't have to wait. You can final exam is just another assignment, just like any other assignment. So it's up to you. A reflection assignment, you can do it at any time. But it's up to you. Questions? 15th of the April? April 15? Okay. So I can make it do, when do you want it? Tell me when you want it and I will change it. Study guide.